Hi everyone, I wanted to take a few brief moments to talk a little bit about how to choose the right hypothesis test in preparation for your final exam. I've received some questions on which test to use for what type of situation, so I wanted to give you an outlook or an idea of what you should actually be looking for as far as wording of the question. So we have a couple of examples to go over today. Should not take too much time. I'm going to be using the TI-84 for the calculations, so I'll go through some of the menus first. Now, when you're talking about hypothesis tests, on your calculator, what you should be pressing for your first selection is the Stat button on your calculator. After you press the Stat button, if you cruise over to Tests, tests will show you all of your options for hypothesis testing. So this is the place you want to be for your calculator for these types of problems. Now, if we look at some of the wording on some of these problems, this one, number one, says, a recent study claimed that at least 15% of junior high students are overweight. So that's something that's important. At least 15% of junior high students. And then in a sample of 160 students, 18 were found to be overweight. At the alpha of 0.05 level, test the claim. Let's see why my pen is not working. Hold on one sec. Interesting. All right, so if we're looking at this particular hypothesis test, it says 15% of junior high students. That's your first clue on what type of test this is. Anything that has to do with percentages is generally a population proportion test. In a sample, the problem also says in a sample of 160 students, 18 were found to be overweight. So if you have a number of some people out of a sample, then you should be thinking P for proportions. Now, the other thing that you're missing is a standard deviation. So problems that are missing a standard deviation and don't have data values that you have to calculate your own also indicate proportion. So the first thing we need to do is set up our hypotheses. Now, if we're setting them up, they come in pairs, null and alternate. Your null hypothesis is always going to be equals to something. So we're dealing with P because we have a proportion, and it's equal to whatever the assumed value is. So 15% would be 0.15. Now, the alternate hypothesis, the only thing that changes is its sign and it is whatever you're trying to test. So we want to test whether at least 15% of junior high students are overweight. So at least is that amount or greater. So P is greater than 0.15, which makes this a right-tailed test. One of the nice things about the tails is if you have an inequality sign, it points toward the tail. So this one is pointing to the right-tailed test. So our next thing that we need to do is calculate our test statistic. If you are using a manual calculator, we have determined that this is a one sample proportions hypothesis test. So if you're using the formula sheet, we are looking at hypothesis testing. One sample proportion hypothesis test are these right here. So this is the test statistic you should be using. P hat is your x over n. So that's how you calculate that value, and the rest is based on P, which is our 0.15 value. So values you need for your calculator. First, in your calculator menu, you are going to go to the one proportion z-test. This one is a number 5 on my menu, one proportion z-test. And it asks you for a few things. The first thing it asks you for is p sub 0. So p sub 0 is our one from the population. So p0 here would be 0.15. It asks you for your x value. X is the number of people in the sample that have that quality. So here x is equal to 18. Your n value is the sample size, so that's 160. You have to choose your tail. So this is a greater than test. So we choose our right tail and then press calculate. So here it gives me a test statistic. Z is equal to 3.627. I'm going to round to 2 decimal places and 3.63. Now, one of the things to be careful of, my calculator gives me this value for my p-value. It says 1.432 times e to the negative 4. So this p-value here, my calculator display is 1.432 e negative 4. Now, anytime you see that e or your p-value is not bound by between 0 and 1, that means that we have to shift our decimal point. The number's really small. So e of negative 4 means we bring this 4 places and create a new decimal point. So what I actually have for my p-value is 0.0001 for my p-value. Now, as far as my conclusion, your conclusion is always based on the same rule. If your p-value that you calculate is less than alpha, here that's 0.05, then we reject. If we reject, that means we have evidence of the claim. So here, p is equal to 0.0001, and it is less than 0.05. So reject. And when we reject our null hypothesis, what we're saying is that this one is untrue. So we have evidence to support the claim. So there is evidence to conclude that at least 15% of junior high students are overweight. Okay, moving on to the next type of problem. In 2010, the mean expenditure for auto insurance in a certain state was $806. Okay, so let me stop right there first. It says mean expenditure. So anytime you see the word mean or a standard deviation in your problem, that means we're dealing with mu. So this is a problem that has to do with means. So it says that the mean was $806. An insurance salesperson in the state believes that the mean expenditure for auto insurance is less today. Just going through and highlighting the important words. She obtains a simple random sample of 32 auto insurance policies and determines the mean to be 781 with a standard deviation of 39.13. Is there enough evidence to support the claim that it is less at the alpha of 0.05 level? Okay, so when you are dealing with a means problem, on your formula sheet, it says that you have 2 different test statistics to choose from. Now, on your calculator, you should be choosing for one sample from numbers 1 for z-test and number 2 for t-test. So you have to pick one of those 2. Now, here's how to tell the difference. If you know sigma, and sigma is the population standard deviation, then you use z. If you don't know sigma and you're given a sample standard deviation, then you use t. But how do you tell from the problem? So the problems themselves just give you, sometimes they just give you a standard deviation. So if I'm looking at this, here it says she obtains a sample. She obtains a sample and she calculates the mean, and the key words are with a sample, with a standard deviation of 3913. So since that standard deviation is in the same sentence with the mean, it means that she calculated it along with her sample mean. That makes this standard deviation an S value. And if you have a sample standard deviation, then you're going to use a t-test. So here we're going to use a t-test. Now, creating our hypotheses, our null and our alternate hypotheses. Here, mu is equal to 806, and the claim is that it's now less than that. So we have a left-tailed test. The information that we need to put in our calculator. We need mu, that's the number from the population. We need x bar, that's the number from our sample. We need s, and we need n, our sample size. So picking out the information from the problem, mu is 806. Our x bar is 781. Standard deviation 3913. And our n is 32. So if I use my calculator for that t-test, I'm using stats and not data. And my x, or my mu sub 0 is what the calculator says is 806, x bar 781, sx 3913, n is 32, and we have a less than test. All right, t is equal to negative 3.180, and our p-value is equal to 0.0017 to 4 decimal places. Now, if you are using a table and you need to find a p-value for t, there is one additional step. So if you're looking for a p-value for t, then what we need is what's called the degrees of freedom. So degrees of freedom is always equal to n minus 1. So here, 31. And if I look at the table itself, I'm looking for a test statistic of 3.180. So going to 31 degrees of freedom, notice that it has 30 and 35. Anytime you are between values, you always choose the next one down. So we would use 30 in this case. And I'm looking to frame between two columns 3.180. So if I go across, 3.18 occurs between these last two columns. So my p-value is for a one-tailed test between 0.005 and 0.05. So from the table, 0.0005 is less than p is less than 0.0005. So those values, my p-value falls between. And you see that this p-value is between those values. Now, how to determine your conclusion? Same rule. If p is less than alpha, and alpha is 0.05, then we reject and we have evidence. So here, since 0.0017 is less than 0.05, we reject. And conclude that insurance rates are lower. you know that that's a made-up problem because insurance rates never get lower. All right, moving on. In 2010, the mean number of pets owned per household was 1.9. A poll of 1023 households conducted this year reported the mean number of pets to be 1.8. Assuming sigma is equal to 1.1, is there sufficient evidence to support the claim that the mean number of pets owned has changed since 2010 at alpha of 0.1? So a couple of key things. We're looking at means again, so we need to pick between z and t. Now, the difference in this problem and the last one is it says assume sigma is 1.1. That means that we have sigma and not s. If you have sigma given, that's when you use a z-test. So hypotheses for this, mu is equal to 1.9, and it says has changed, which gives us not equal to a two-tailed test. Our test statistic, z-test, with mu equal to 1.9, x bar equal to 1.8, n equal to 1023, and sigma equal to 1.1. And we have not equal to. All right, this time I'm getting z is equal to negative 2.91 to 2 decimal places. Now I wanted to, this gives me a p-value too, but those of you who are using a different type of calculator, I just wanted to show you how to get the p-value from this. So if I am looking at our standard normal table, the first thing I have to decide is, do I have a one-tailed test or a two-tailed test? If I have a one-tailed test, I can pull a p-value direct from the table. If I have a two-tailed test, I have to multiply what I have by 2. So this is a two-tailed test where we calculated negative 2.91. So I'm going to the negative 2.9 and 1 gives me 0.0018. So from the table, p is equal to 0.0018 times 2 for two-tailed, or 0.0036. Those of you using the calculator, you should have gotten 0.00364. It gives you a little bit more accurate p-values, but 4 decimal places is fine. This one we'd reject as well. Have questions, please let me know, and good luck on your final exam.